So I'm very pleased to move on to our first speaker, who will give us a general overview of the district heating and cooling market, and outlook, insights, and trends. And we're very fortunate to have Andrej Jentsch, who's the program manager for the International Energy Agency technical collaboration program on district heating and cooling. So we're looking forward to your overview of district heating around the world. So the floor is yours, Andrej, and you can go ahead and share your slides as well.
Thank you very much, Hans. Very nice to be here. Honored to have been invited to this prestigious event. So I hope I can provide some interesting insights into district heating and cooling and how it relates to CHP. I think that's always the bridge here in this event. So yeah, let's get right to it. I just start my timer so I don't talk too long. IADHC is a research collaboration program. We're essentially funding research on district heating and cooling, including combined heat and power. So we have many research reports available on our website in case you might be interested in the newest developments in district heating and cooling. And with that, I jump right into it, into the first slide. We have here this share of CHP heat in district heating and cooling in Europe. And as you can see, it's very diverse. So we have 100% in Portugal, Kosovo, and we have 1% in Norway. So the deployment of CHP apparently varies greatly based on the country's situation. However, in average, it's in Europe 42%, which is quite a substantial element considering that we also have boilers, renewables, waste heat, etc. So CHP is a key player in district heating and cooling, and probably traditionally the technology that makes it sensible. Because obviously you have network losses in district heating and cooling, but efficient CHP plants offset these network losses through their efficiency, thus bringing benefits to the customers that you cannot get by using boilers. The share of district heating and cooling in Europe in residential and service sectors is about 12% for space heating and domestic hot water. 43% comes from waste and renewable sources. So as we've seen, 42% come from CHP. That means about 15% are from boilers. 70 million people are served in Europe, and we have a predicted growth up to 50% of the complete heating market. So district heating is indeed, after a long sleep, beginning to boom because more and more countries realize that this infrastructure allows the most cost-effective provision of green heat to customers. Also, it's very comfortable as customers usually don't have to deal with complicated units at their own sites. So as you can see, the district heating and sales usually go up, as you can see in Denmark, Finland, France, Poland, Germany. Interestingly, it went down a bit. However, as we will see in a minute, this is not a sign of decreasing demand. But on the one hand, we had a very warm year in 2021. And we have better installation, so we have strong regulations in Germany that force or encourage to insulate buildings more, so the heat demand is decreasing. And here you can see essentially that it's really a success story. So we're growing almost in all countries or staying stable, in Europe at least. Germany has grown from 2019 to 2021 also quite substantially, the district heating market. But as you can see, I put the slides sales to consumer on the other side, so you can essentially compare that the extension of the network does not mean you sell more heat. simply because building renovation efficiency measures increase. That means to achieve the same sales, you need a longer network, which also will change likely prices and price structures in district heating. Interestingly, we have Europe-wide trends for more CHP, for more district heating and cooling. I think I have to adapt the slide. I think it's district heating and cooling connections that it says here, not CHP. So we have 350,000 new households for Austria by 2030. In Denmark, 300,000 new households. And it's important to remember that it's not very big countries. So it's quite a substantial growth. Denmark already has a significant share of district heating and cooling of about 60%. So they're still growing. France, coming from a rather low baseline, also increases district heating and cooling. Germany wants to increase by 300,000 to 600,000 households per year, which is extremely ambitious. And Scotland also by 2030, 650,000 households. Netherlands also growing. So all or many European countries are growing district heating and cooling as a means to tackle climate challenges and to allow for a greening of heat without measures taken on site at the consumer, like at least measures that build in generation capacity. So it's just heat exchangers in this case. So what are the trends? There's a heat roadmap Europe. It's admittedly a bit older, but I think since then it has improved. As you can see, the perspectives for CHP in district heating are still very good in 2050. So it will be key technology. Large heat pumps will obviously rise, as you can see in the green section. Geothermal CHP can also become more and more popular. There are new technologies being tested that could enable geothermal heating and CHP everywhere. Yeah, and as you can see in this future, there is no gas boilers anymore. So one of the key technologies for heating of the past will be phased out largely in 2050. And from my perspective, that's a very good thing because it's a very inefficient technology from the exergy point of view, which is more comprehensive than energy, but more to that in a couple of minutes. We have also cooling in our name and also on the presentation. So as you can see, we have also some statistics here for district cooling. In Europe, we have about 3,000 gigawatt hours per year. But it's important to notice that it's much lower. So the maximum district heating capacity per country is about 100,000 kilowatt hours. Here in cooling, we are about 1,000 gigawatt hours per year. So the factor or the ratio of district heating to district cooling is 100 to 1 in terms of sales. That means it's still a very dominantly a heating market, at least in Northern Europe. Yeah, that we will see how that develops. I think district cooling is growing to a large extent. We don't have numbers on that yet. But as you can see, also the district cooling network is much shorter than in the district heating network, about 50 to 1. That means we need more trench length per sold unit than in district heating, which makes sense since we have lower temperature differences between forward and return, and also the cooling season in Europe is much shorter than the heating season. Since it's a World Coalition meeting, I wanted to also point out some interesting facts about China, which is the largest district heating and cooling market globally. They have 313 million people connected to district heating. It's 4.5 times the amount of Europe, of the connections in Europe, so about half the European population at the moment. They have very extensive growth, so 210% in 10 years. So it's almost like if you would an average growth of 21% per year. 30,000 kilometers per year is the growth. So it grows essentially by the trench legs of Germany every year. And they have still high, but decreasing carbon emissions, as you can see in the last column. So 2017, it was still 378 tons of CO2 per gigawatt hours, and now it's 296. So we're approaching essentially the emissions of a natural gas boiler. But this is just the beginning, and I think considering the developments, we can be quite confident that the decrease of emissions per unit of district heating in China will continue. In terms of CHP, the share has grown in China, so which is also interesting. So China is one of the countries that is expanding CHP significantly. When we were there, they told us, for example, they connect all condensing power plants directly to the cities. Even if they're far away, they have a method of having very high temperature split between forward and return flow for these transport lines, and the condensing power plants can be up to 100 kilometers away from the city and still provide heat from CHP in this case, which obviously saves, again, lots of emissions and helps to green the heat and combat climate change. This is also a very interesting figure in my perspective. It shows the trends in Chinese district heating over the years. And as you can see, 2020, there's still significant fossil fuel boilers, which are in 2050 completely replaced with other technologies. So there will be heat storage, industrial waste heat will increasingly play a role, but also waste heat of nuclear power plants, which essentially means nuclear CHP and traditional CHP from using green gases probably, but maybe also geothermal CHP. I don't know exactly how they separated here the renewable energy part of geothermal energy. So yeah, that's mainly a big overview, I think, for the world. So CHP is growing, district heating is growing. It's a very strong technology. But as you said, the awareness of CHP benefits is not, let's say, very high everywhere. So there is still a need to explain combined heat and power, even though the technology is very, very old as an idea, and brings lots of benefits for over 100 years now. It's still not completely understood why. And the background is that the analysis methodology for CHP assessment is not very consistent. Often it's there's people try to use reference values from other technologies, and the reference values obviously can be cherry-picked, can be also just they mirror how things are, which doesn't mean that it's good the way it is. So they distort the results, but there are ways to do it differently to assess district heating and cooling in a more consistent way, so that can be compared with individual solutions, that CHP can be compared with boilers, with renewables, etc., in terms of its efficiency gains. And it avoids essentially the many issues with primary energy factors that arise now that we have renewable energy to a large part in our networks. So there's this new guideline for resource exergy analysis. We've developed it at AGFW. It's free to download. There's also an English version. It allows essentially to compare all technologies in terms of their gains by reducing resource consumption. So resource consumption kind of can replace primary energy consumption as one of the efficiency guiding indicators. And here's just an example how this can look like. In IEA DHC, we had this year, we finished an NXTS3, it's hybrid energy systems. And we did a resource exergy analysis of these hybrid energy systems. also with some reference values. So scenario 1 is natural gas condensing boiler. Scenario 2 is classic district heating with CHP and natural gas boilers, but only 50% CHP. So what you see is essentially half the benefit that a full CHP could bring. Scenario 3, air source heat pump. Scenario 4, district heating with large heat pumps, but very efficient ones, only providing about 50 degrees, and then at the site, topping it up for domestic hot water disinfection partially. Then we have cold district heating networks, as they are called, those where you have essentially thermal source networks where decentralized heat pumps then lift the temperature, and district heating using geothermal heat directly, this time without CHP. And what you can see is quite interesting is that the indicators cumulated primary energy consumption and total primary energy consumption actually show that this CHP is negative or doesn't have any benefits over a boiler. So 0% is a boiler because it's a savings here in this diagram. The light gray fossil primary energy consumption, yes, it is an interesting indicator, and it can also help to already assess CHP in a rather reasonable way. However, it does not allow comparison with renewables, since all renewables are equal because they don't have any fossil parts anymore. So that's also not very helpful. And as you can see, if you use the indicators resource exergy consumption and greenhouse gas emissions, these are two complementary ones. One showing essentially the sufficiency of the whole system, which decreases indirect emissions, and then we have greenhouse gas emissions, which shows the direct emissions. So you can maybe later look at this or download the full report if you're more interested in this. So I think we need more awareness of the CHP benefits, which are pretty huge. So with natural gas CHP of high efficiency, you can already save 50% of emissions compared to a boiler, which is very substantial. And that means you didn't even do a fuel switch. So it might be a first step towards decarbonization. Summary, so DHC is booming, CHP is and will be a key element. There are large variations in experience and deployment of district heating and cooling. District cooling currently is much less relevant than district heating. For an accurate benefits assessment of district heating and cooling, including CHP, I think this resource exergy analysis is required because exergy can assess the energy quality of heating. It can take that into account. And there's still many challenges on legal, financial, and practical level, as you probably all know, but they can be overcome with innovation, collaboration, and education. And I think we're doing exactly that here. So thanks very much for your attention. And if you have any questions, please contact me. Thank you very much.
Thank you, Andrej. Thank you for your comprehensive presentation. Very interesting. And clearly district heating and cooling has a strong future ahead of itself, and CHP still has a strong role in supporting that.